All right. Well, welcome everyone. Thanks for joining this. I personally already got quite excited with the previous presentation. Originally, I'm from the Netherlands, and therefore I'm actually one of that 40% that is a big favor of windmills, despite I don't live there. It's actually cool how they have set it up. I know my folks actually own sort of a couple shares in windmills. It's like a fun way to get the population actually involved. So I'm pretty sure. I'm not sure if that's an Alberta setup, but who knows? It might work here. But we're not here to talk about windmills. So I'm going to talk about really a lot of it oil and gas, but really the key part where we try to provide data-driven emission management to the industry, and particularly to help oil and gas producers, midstream, upstream, and downstream, to help reduce methane. So as a bit of an intro, my name is Stephan Becker. I'm the head of product at a clean tech startup here in Calgary. We've been around for about 5 years. The company's called Arolytics, and I lead the SaaS product AeroVis. So it's a product really focused around methane management for the North American oil and gas producers, to really equip them with the right data for their methane to make the right decision. So it's a very ambiguous comment to make, but you'd be surprised perhaps how complicated it is for the industry to accurately be able to say what their methane output actually is. So I'll talk a little bit about that today. I've been in product for 6 years, and the last 2 years really spent mostly in sort of clean tech and a lot around this methane emission reduction or methane abatement reduction space, and with its very unique sort of problem spaces that we try to help our customers on. So just to give you some info, so methane management is a rapidly growing urgent need globally. There's been a lot of really key movements happening over the last years in terms of different governments coming together globally to say we need to focus on cutting methane. I think we all know CO2 is, to a degree, but CO2 is bad. Methane is even worse. It's about 80 times roughly. I think the number has changed actually recently from some more up-to-date calculations, but it's roughly about 80 times more potent than what comes out of your car. So with that, there's a lot of focus on methane reduction. And with that as well, the oil and gas industry or sector, given that if you look at overall methane output in sort of the world, it's led by oil and gas, agriculture, and then sort of a lot of different other sort of mix, but oil and gas certainly is a large one. And interestingly enough, all the methane that is being leaked during oil and gas production equates to about $30 billion lost revenue globally as well. So it's not just bad for the planet, it's as well an interesting ROI almost for the producers to actually spend more focus on reducing their leaked methane. But as we're going to talk a little bit about right now, is that it's hard, complex, and ambiguous for producers to actually proactively know where is my leak methane and how can we actually start cutting that down. So some more info based on sort of where the market is at. So through what was called the Global Methane Pledge, over 120 countries have recently agreed to cut their methane with 30% by 2030. Quite a large amount, and exciting enough, Canada, and specifically with that as well, Alberta, we're actually quite progressive at it. We were on track to actually succeed that target, and it was actually increased to actually go over it because we're doing so well actually as a country. So certainly a bit of a pat on the shoulder for Canada, to be honest, and how well we're doing in our methane reductions. But how we got there, really, there was a lot of focus from different regulatory bodies who were creating processes and reporting frameworks for the industry. So to the question that Dominic actually just put in, that's been a major one where the Canada climate change came in and started putting up different regulations to basically make it mandatory for oil and gas producers to look after the methane. A lot of it is around the measure, reduce, and report emissions from their facilities up to 4 times a year. So it could be once, could be up to 4 times, depending on a couple factors. And as well, there's been a really good growth in terms of voluntary certifications and standards that are making a difference. So one layer you got, your government coming in, setting rules and regulations for producers to be compliant with. But the other part, luckily through the public, you and me kind of thing, both public and private companies are seeing the pressure, and they're starting to sign up with different voluntary initiatives that make them go above and beyond even what the regulations are asking for, which are having quite an impact as well. But from all of this, and this is kind of where Arolytics comes in, there's a lot of large data challenges. There's a lot of operational inefficiencies and very complex frameworks. That doesn't always make it actually easy to follow the regulation for the producers. So there's a lot of ambiguity unknown in this, for which to a degree they're looking for the right experts and products to help them with. So kind of cue Arolytics. So we try to, with the focus on methane, we have sort of what we call this methane management journey, where we have a whole team of emission analysts who our expert services team, where we try to guide the different producers, or oil and gas producers where we work with, or we guide them through. Basically, this is kind of where you're at. This is perhaps some sort of success criteria or perhaps targets you have, right? Like, is it hitting compliance? Is it a certification standard? What might that be? And we try to give them that, expertise to get them started. From there, we have a modeling product that helps them build the right strategy to get there. So, to give a bit of a rough example, I'll get more detailed later. It isn't just, okay, let's go out, find my methane and start stopping, no longer have methane. It's quite a bit complexer than that. It isn't just let's put solar panels on and we're done. There's a lot more to it, which again, I'll talk about. But we help them build this through a modeling product that we have. And then from there, we put it together in our actual SaaS product called Aroviz, where we really bring all the different data pieces together, where they get the right insights through different dashboards, different reporting tools, different automation tools, different communication with operations who are in the field in order to really execute on everything we've helped them prior to that. So here's a key one to understand, I think, in order to get a grasp even more of how complex this space is. So when I mentioned earlier, different regulations are involved. There's a lot of focus around methane, but particularly in leaks. So I'm really dumbing it down. So if there's any experts on the call, I apologize. I am intentionally doing that for the case who aren't experts here. But if you look at what the regulations are talking about, when you look at methane, when you look at oil and gas in their facilities across, let's say, Alberta, there's always leaks happening. There's always some screw that got loose. There's something broken, causing methane to be leaking in the air. And because you can't really see it, you could smell it. There's some ways, but you can't really just drive by and see if there's a leak. Part of the regulations is about what's called fugitive methane, or leaking of methane. And where the regulations come in, we say, we want you to go out to all your facilities up to 4 times a year, basically drive out to all of them, grab a very fancy infrared camera, and use a camera through that infrared to see if there's any methane leaking. Now, that's sort of the basic compliance, if you will. Very complex, very operationally inefficient. And there's some pros and cons with that camera as well. The camera can't see everything. If a leak is on top of a tank, all the way at the top, that if you're standing on the ground, you cannot see, the camera won't pick it up. Now, this is then where alternative tech starts to come in, where, as you can see in the image here, there's a pickup truck. There's you see a little thing with a solar panel image that's called a continuous sensor, basically a webcam on your facilities that just scans 24/7. You can deploy drones, you can deploy airplanes, and you can actually start using satellites. Now, where we try to help in is that an oil and gas producer, they have all these options to get more accurate in measuring their leakage of methane, but what to pick. There's pros and cons with all of these. The webcam, for example, it sits there 24/7, but it can only look at a certain area, right? A satellite is very obviously from space. It can see a small leak. Um, a drone, it can see more, but you still means you got to drive to all your different sites and deploy the drone. Truck, same thing, drive around. Airplane, again, a little better, much more efficient, but again, it can't see everything. So this creates a bit of a complex, sort of problem for producers to say, what should I deploy? What tech should I deploy in order to get the most accurate in terms of measuring and finding my leaks and acting on them the right way? Now, this is kind of where a part of our modeling product comes in, is that we work with our customers to understand their facilities, their uniques, where are your sites located? From previous work they would have done, we have some level of a footprint or baseline, have you, of what their methane has been and what they have discovered so far. And we have a large library of different models that we can run to give them a sort of best bang for your buck recommendation. Based on where the market is or the industry really is today and the technology is today, there isn't just one rules them all. It's just finding, again, based on what you're requiring, what's the most efficient way to go for. As an example, you might have a producer who only has 5 sites in a small area near, let's say, Fort McMurray. Potentially a webcam continuous sensor works best. But if you got them scattered all across the province, the satellite might be more efficient, right? Hoping that kind of makes sense. So this is an example of where we do the modeling for our customers. So we evaluate and compare the different technologies. We look at what are the optimizing of the cost and the emission reductions. Again, a satellite, comes with a certain cost. It can see a lot of stuff, but it can't see everything, right? So we run a whole bunch of different scenarios through what's called a Monte Carlo sort of run. And then we get to do some form of forecasting into potential methane emissions based on what we historically know, or based on what we actually know of data, what we have of other customers. So this example here, it takes a little bit of explanation, but essentially these lines, these dotted lines represent sort of the cost for their baseline and the amount of emissions they have on the baseline. So basically this horizontal line displays the methane or the emissions they had outputted in the past. The vertical line is sort of the cost they have spent so far. Sorry, other way around actually. But this crosses essentially what it looks like for them today. Now, if they want to deploy different technologies, anything that lands within this box at the bottom left is then a more efficient way for a customer going at it. So this could be a combination of, okay, start with an aircraft, do that 3 times a year, and then use your camera, the actual person driving to the site, to look with an actual little infrared camera to then confirm the leak. So I hope I haven't lost you. I appreciate that's quite a complex area, but it is a complex space, and we're using this modeling. What we're helping to get producers to is that they can find the most cost efficient, but as well emission efficient way of finding all these methane, plugging their leaks or finding their leaks and fixing them as fast as they can. So from there, where AeroVis really comes in is this big part of data management. So as I mentioned previously, you have all these different companies who provide excellent data. The problem often for the producer in the middle is that they have a lot of data in different products, right? Different software products. So there's, you got 5 different logins, for example, where you're all going to review and try to put the pieces together. It is actually quite complex. Imagine doing your accounting, but you have it scattered through 5 different accounting platforms, and each of them only track a specific expense. And then put all that together is a ton of work and quite, as you can imagine at that point with that example, quite complex to do. So we really try to come in, bring everything together, give them as well a real-time performance of what their methane emission looks like. We really help them on this process called LDAR. So not to be confused with LiDAR, which is a sensor. LDAR is a process, stands for leak detection and repair. Help them really actively reducing targets and a lot of these items as well around workflow management. As you can imagine, if a satellite discovered the leak, for example, found methane, that information has to travel all the way down to your technicians out in the field who would then learn about that info, know where they need to go to then fix that leak, and then report that back upwards. So that's a lot of complex operational work where we are quite focused on making that efficient for our customers as well. Um, and then from there, we as well help with automated compliance. Again, the key part for a lot of our customers, obviously, is to be compliant. And as well, those that go a couple steps beyond, give them key ESG analytics so they can start putting out public statements about, methane reduced, certain targets that were hit, and other key targets they're looking for. So just to give you kind of, product manager, I'll give you a bit of a product lens to this all in case there's any PMs or others who are curious on the call. Things that we just hear a lot in this space is that, as I was kind of mentioning a little bit, it's hard to efficiently source and process a wide variety of data. This is the big one, really, is that we're trying to accurately quantify and what's called no longer use factors of our methane emissions. So today, the industry relies a lot on basically saying, I have this piece of equipment from this brand and this manufacturer, I should say, and in a lab environment, they're able to say if this is how much methane it could output. And they use it as a blanket factor, a blanket calculation, if you will, to calculate what their methane output is. Obviously, that's, as best they can in the lab, it's not an accurate representation of what is actually happening. So a lot of the really that are having really good, public pressure or public targets, they're trying to actually quantify what is happening out in their fields and not rely on a factor, a calculation that is made in a lab, but actually what happens outdoors. Big part is efficiently conduct my leak detection and repair process. So example I just gave, right? It's, something was detected from a satellite. Now you need to send a guy out in a truck to go fix it. Companies are trying to move towards voluntary standards. And I put it here kind of in this bit of a tongue-in-cheek comment almost, but that aren't defined yet. So nothing wrong. They're ambitious. There's some very important, very good standards out there. But some of these levels, companies have pledged they want to get there, but there hasn't been very strong, accurate models that can actually get them there yet in terms of that, what I mentioned earlier, to actually very accurately say with a high degree of accuracy, this is my methane output. But companies are moving there, which is excellent. As an industry, we need to start helping these companies to actually get to these standards with the amount of measurement that is required. A lot of questions obviously about how can I be most cost and time efficient. And respectfully, I get, there's a certain level of amount of budget and time you want to allocate to it. What's the best ROI, right? We can help them keep, leaking methane, leaking gas back into the pipeline, as well as reduce emissions. But how far does a dollar travel? So, we're trying to, that's a big, big question at the same time. And as well, looking for unbiased advice is something we hear a lot. Imagine first time you're doing your taxes, find the right one that gives you unbiased advice that you get the most, out of your tax returns, for example. And similar thing, I would say, in this industry as well. So kind of bringing it together, right? So as a government, Canada is really good. US is starting to announce now their regulation, which is quite exciting as a US overall. There's a lot of stuff in the Inflation Reduction Act you might have heard about. There's a couple key subparts in there. Or ones particularly that starting to get some really key targets in the US as well, a lot of what you've seen in Canada. But there's a big targets to meet compliance and therefore reduce methane emissions. The challenge really for the producers out there is that it's a lot of ambiguity to meet these targets. There's a data overload and a very efficient process. We're trying to bring it all to more of a future state where we're giving them modeled recommendations, right? Best way, most efficient way to going at it. Make sure they're efficient, consolidate all the different data to actually help them make the right decisions about where to go, where to prioritize their efforts to really see them reduce methane emissions and start reporting these as public numbers. And that's, a big part of how we try with our product to put that together. So Again, back for the product manager, in case they're here, in case you're curious, as we're talking clean tech, and I think a lot of that's on the audience. Um, a lot more we're looking at is, we need to solve quite a bit for don't know what we don't know. As I said, regulations are coming. At the same point, the market is changing. At the same point, standards are coming up for future state targets for companies to hit. And customers don't know today what their problem is going to be in the future. So a lot of the work we do is trying to understand, what is a future state for all these companies, and how do we build a product for that future state? Again, some tech companies you might use today, any products you might use today, they'll look at you, they might interview you, they see your current product usage, and they'll solve problems and give you solutions for stuff you need today. Again, let's take the example of doing your taxes. Very clear how that works today. Come February, when our taxes are coming, they can solve for that. We're really in the market where we need to be very innovative driven, very much looking out into the future of, if they need to achieve certain standards there and achieve certain data, kind of this sort of darker green color here, we need to do our work today to ensure that happens. So a key example here, one of our company's founders, Dave Risk, he runs a key lab out in Halifax, and they're very leading authority. He's a very leading authority on methane. He works with different government parties as well to support them and provide them with the right advice and evidence. But we're working from his lab to do the research today, so we can provide the accurate, a certain level of accuracy in data 12 months from now, for example. So it's a very innovative way of looking at it to give we're tracking all the data, we're getting our companies to get all the data in today to build this big database, so that a year from now we have everything and we can give them the right calculations and the right solutions to actually know their inventory. And then, in case you're familiar, a lot of the work we do is called around the Kano method, or Kano, I think it goes by Kano. It's a lot of figuring out the right ways to build key problem-solving products, so like meeting compliance, but at the same point adding some key, very sweet features, if you will, that adds a lot of great customer experience to our product, that visualizes the data to really lower that barrier of this mass amount of data that's getting at them. And really, we have, for us, a bit of a purpose in our own day-to-day jobs is by lowering the barrier, we can have an impact in terms of global warming, right? The easier we can make it for a lot of these companies out there, the hope with that is that, they can act on it better, and then we can help them reduce the targets even further than they might have thought. And the last one here on the right, this is about a key framework we tend to follow a lot, which is called service design, a very UX-driven framework, or from a UX side. And this is an example you see here. There's a lot of stuff that happens backstage in order for the front stage for you to have a great show. Same example here. If we want to equip our customers with the right amount of data to know very accurately what's happening with the methane, what is going on, why is this leaking, you need to make sure that all the way down into the field, all the data is being captured. So something very small like, what was the reason of the leak? Basically, a bolt was loose, or this rubber flange was broken now for the third time. That information over there needs to be captured very accurately and well in order for this big, complex question to get answered, right? So I kind of hope that makes sense, but that service design framework is absolutely fundamental in the way how we do software development or product development here, because without that little piece of detail about what broke, for example, over here, they cannot make the right decisions. Otherwise, it's just a bunch of assumptions, and assumptions don't really work well when we talk about emission reductions. So quickly, 2 more slides. So Arovis is our product. It's really about making sense of your data. So a few screenshots here. As you can see here at the bottom, there's, for example, an image from, I think this is aerial. So it shows you, for example, methane leaking, and then we give that data to the customer so they can see through different GIS visuals, what methane is happening on what location in the province, And then with a couple clicks, they can basically send their operators out, who would then use our app to basically find again that leak that was detected by the airplane. Then you confirm it with a special camera, and then confirm they repaired that, and that information flows back up to the product. And that's a key cycle if we're talking about being compliant with what the government is sort of mandating. Yeah, that was it. I put some questions in here, challenging questions in case the Q&A is quiet, but thanks for your time. If you're happy, more than welcome to find me on LinkedIn. Happy to connect or talk anything about methane and oil and gas, anything in that regard.